Day 243 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem. This time we're at day 243 and we're still going strong, y'all. Today we have question number 230, kth smallest element in a BST. The difficulty level is medium, but you already know we're going to keep the solution as simple and easy to understand. So let's get into it, y'all. The question says, given the root of a binary search tree and an integer k, return the kth smallest value, one index of all values of the nodes in the tree. So let's look at example one so we can break that down. In example one, we have the input root equals an array of equals a binary search tree 3, 1, 4, 0, and 2, k equals 1, and the output is 1. So what we need to do is figure out how did they get this output from this input, right? And when working with binary search trees, we know all the smaller numbers go to the left and all the bigger numbers go to the right, right? So we can use that in our traversal, use that knowledge in our traversal so we can do an in-order traversal, right? And what an in-order traversal does is first we traverse the left subtree, then we traverse the root, and then we traverse the right subtree. And if we do that correctly, all of the value should come out in order, right? Because of how the binary search tree is set up, with all the smaller numbers on the left and all the larger numbers go to the right. So let me show you how, right? So if if we do the in order traversal, right? First thing we would do is we would traverse the left subtree. So we come over here, we see the first one would be null. So we could just put a null. Then we come over here, do the 1. Boom. So then it'd be the 1. Then we come down here and do the 2. Boom. Now we just traverse the left subtree, right, from left to right, same way. First we do the left, then the root, then the right. Boom. Now we have to go, that's just the left subtree though. Now we have to go to the root. So the root is 3, so we put a 3 right here. Boom. Then we come down and we traverse the right subtree, and the right subtree is just a 4. And as you can see, these elements are in order 1, 2, 3, 4, as we did the in order traversal of the binary search tree, thus the name in order. Now all we have to do is find which is k, right? So we know k is the smallest number, right? So this is null, so we can exclude that. And then 1, k equals 1, so k, this would be the first smallest number because it's already in order, right? So just say, for example, k was equal to 3, then this would be k would equal 3 because it's in order. So that's how we are able to find the kth smallest element. So let's look at example 2 where it might be a little longer of a binary search tree, but it's still the same principles, right? So in this case, we have the input equals a root equals a binary search tree 5, 3, 6, 2, 4, 0, 0, 1. This time the output, and k equals 3. This time the output is 3. So we're doing the same thing. We're going to do the in order traversal, which is going to put the elements in order for us, and then we just need to find the kth element. So let's just draw that out so it can make sense. So first, in order traversal, first thing we do is we traverse we start from the farthest left of the subtrees, or the farthest left node, which in this case would be 1. So we put the 1 right here. Boom. So we put the 1, then that'd be the left subtree of this root of 2. So we go 1, then we do the 2. Boom. Then we see the 2 is null, so we put a null right here. Boom. Then we traverse that subtree. Now we need to do the root or the rest of that subtree. So then we come up to the 3, do the 3. Boom. Do the right of that subtree, or the right of that node, which would be 4. Boom. Now we do the root, the original root, which would be 5. Now we come over to the right subtree of the whole binary search tree and we do 6. So now we know that the elements are in order. Now after we do that, we just find the kth element, right? So null, we could get rid of null because null is just null, is nothing. There's nothing at null, and then we find the kth element, right? We go 1, 2, 3. Boom, that's the kth element when we do the in order traversal and all the nodes are in order, we find the kth element, in this case 3, thus the output is 3. So that's how we're gonna do it. We're just gonna uh, do an in-order traversal and find the kth element in that traversal. So now that we understand the solution, y'all, now that we understand the question, y'all, let's get into the fun part, the actual solution. But before we do the solution, y'all, don't forget to go ahead. If you need any new Apple AirPods, go ahead and check that link out in the description. And then after you do that, don't forget to like, comment, and subscribe, y'all. Now let's get into the fun part, the actual solution, right? So the first thing we need to do is we need to create a helper function that's going to perform the in-order traversal for us, right? So, and this traversal is going to visit nodes in sorted order, like I just showed you how the in-order traversal works. So in order to do that, we're just going to say func. Inside this main function, the kth smallest function, we're going to say func, call that traverse, open up the parentheses, underscore node, colon, tree node, tree node, question mark, come outside the parentheses, is going to return an array of integers. And now we can open up our brackets, right? So the first thing we need to do is we need to check to see if a binary tree actually exists and it's not just blank. So in order to do that, we could just say guard let node equal node, else open up the brackets, we can just return, right? Now it's time to perform the in-order traversal, right? So first thing to perform the in-order traversal, first we need to recursively visit the left subtree, then we need to add the value of the current node, then we need to recursively visit the right subtree of that node, right? So in order to do that, it's going to be, we're going to say return, then we're just going to say traverse like that, open up the parentheses, node.left. That's going to handle the left subtree. Then we're going to come outside, we're going to say plus, boom, we're going to say node.val. That's going to handle the root. And then we're going to say plus traverse, open up the parentheses, node.right. And that's going to handle the right subtree. Now, all we need to do is, now we need to find the kth smallest element of that traversal, right? So, and since the arrays are zero index, we are going to do it like this. We're just going to say return traverse, open up the parentheses, root, come outside those parentheses. We're going to say open up the square brackets and say k minus 1 because, minus 1's equal white space on either side of the minus sign. But because it's zero index, we're going to say minus 1 just to handle that zero indexed array that we created. So now that should be all she wrote, y'all. Let's run it. Let's run it, see how it runs. Make sure, okay, so what does it say? Oh, sorry, y'all. This needs to return a blank array, not just return, should be a blank array. Now let's run it, y'all, and it's accepted, so let's submit it. Let's submit it, make sure it stays accepted, y'all. Ooh, and look at that. Y'all, 0 milliseconds beats 100% of users with Swift, y'all. You already know those are some good numbers right there. Those are the numbers I like to see. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. I will see y'all then.